In this lesson, we'll examine another implication for our study practices based on our knowledge of how brains are processing information, how brains are making memories. We want to get quality sleep. Sleep is very, very important, because what we'll learn is that during sleep, we are consolidating cortical memories and refreshing our hippocampus for new learning. Let's return to our brain after one study session. We were left with weak memory traces in the cortex, strong memory trace in the hippocampus. But to be educated would be to have strong memory traces in the cortex. Remember, the cerebral cortex is the long-term memory system, and we want to have strong memory traces there so we have easy and fast access to all that information. So how do we strengthen these cortical memory traces? And here's where sleep comes in. Scientists have discovered that during sleep, our brains are reprocessing recently learned information. And we're going to be calling this memory consolidation. So this is a biological process in which temporary memories, and we'll think of the hippocampal memory traces as temporary, are transformed into stable and long-lasting form. In particular, what we're going to be doing is strengthening the cortical memory traces, so that we won't need the hippocampus any longer to access that information stored in the cortex. Now, the way to think about this is that during sleep, our brain goes into a phase where the hippocampal memory traces that were formed that day get reactivated, and we can think of this as hippocampal replay. And when you reactivate the hippocampal memory traces, they are now going to be sending signals up to the connected cortical memory traces. Remember, the hippocampal memory trace was linking together these cortical memory traces. Now the information is flowing in the opposite direction. The hippocampal memory traces are reactivating the cortical memory traces, for the purpose of which is to strengthen those cortical memory traces. So now the neurons are being activated, and they can grow stronger synapses between those neurons in the memory trace. In fact, scientists estimate that the rate of firing of these hippocampal neurons is accelerated by a factor of 20. So a single learning event that we had during the day can be replayed hundreds of times during these stages of sleep. So you're really kind of giving a good workout to your cortex when you're asleep. You're totally unconscious, but your brain is reprocessing recently learned information, the purpose of which is to strengthen these cortical memory traces. And how is that possible? Because the hippocampal memory trace is linked to those cortical memory traces, and these hippocampal memory traces get reactivated during sleep. Using our analogy of a hard drive, then, we are sort of writing the data to the hard drive. If the cortex is the hard drive, we're kind of strengthening the cortical memory traces in the cortex, and that would be like writing data to the hard drive. In addition, it is during sleep that scientists think these separated cortical memory traces are going to be linked together so that we can associate what we saw with what we heard, with what we felt, and so on. And you recall that's how we sort of form concepts. And in addition, we're going to be able then to link new knowledge with old knowledge stored in the cerebral cortex. We saw this in an earlier lesson where we have visual memories stored in visual areas and auditory memories stored in auditory areas, but we don't want them to be isolated. We want to be able to associate what we saw with what we heard. So there are regions of the brain that are positioned to do exactly that, to receive inputs from these auditory memories and visual memories and link them together. And the example we used earlier was the concept of a tiger. So the concept of a tiger includes what a tiger looks like, what a tiger sounds like, what a tiger feels like, then the sound of the word tiger, or other facts about tigers. We're going to link them all together, forming our concept of a tiger. And this kind of integration is thought to occur during memory consolidation during sleep. Now, why do we do this consolidation during sleep? Well, notice, when we're unconscious, we'll have no interference from ongoing sensory processing. See, if we've got to, strengthen cortical memory traces in the visual cortex, that's what I saw that day in class during some lesson, well, I don't want to be continuing to see stuff. I don't want to be activating my visual cortex while at the same time trying to strengthen specific memory traces. So what we have going on here during sleep is that we're unconscious. So we don't get this interference from ongoing sensory processing. And now the brain can do this memory work without that interference. Why consolidate at all? Well, the idea here is that one idea is that there's just more synapses in the cortex, so there's more storage space. So the cortex is where we want to store our long-term memories of all the information we're learning. We're just using the hippocampal memory traces as a way to strengthen these cortical memory traces over time. If we look at some numbers, now these pictures you see, these are pictures of a rat hippocampus. But in a human, the hippocampus might have something like 50 million neurons. So these little purple things would be neurons in the hippocampus of a rat. But let's imagine this is a human. So say 50 million neurons in the hippocampus. But in the cerebral cortex, here we see a slice through the brain on the left. And let's just take a little section of cortex there. Here is another slice through the brain, and the cells have been stained with a purple stain. But this is the cortex here. The cortex might have something like 16 or 18 billion neurons. So again, the difference between the hippocampus is 50 million neurons. So there's a lot of synapses there, but if you have 16 billion neurons in the cortex, you have even more synapses. You have much more storage space for memory traces. So we want to get quality sleep. We're going to be consolidating cortical memories. But now let's look at the other process that's happening during sleep. We're going to be refreshing our hippocampus. So the first stage of sleep is the consolidation phase. We're going to reactivate hippocampal memory traces to strengthen cortical memory traces. But then scientists think the brain goes into another phase, a different phase of sleep, where, interestingly, curiously, the hippocampal memory traces will be weakened. In fact, scientists think some of the cortical synapses are weakened as well, but the hippocampal memory traces are going to be weakened. And we'll think of this as refreshing the hippocampus, preparing it for new learning. Let's think about it this way. Plasticity has limits. So when we're awake and we're learning stuff down there in the hippocampus, remember the hippocampus has high plasticity, so we are strengthening those synapses between hippocampal neurons when we're awake. But there's a limit to plasticity. You see, if these synapses are already maxed out, if they cannot be strengthened anymore, then I cannot learn anything new. So learning requires the ability for synapses to increase in strength. If I've already maxed out my synapse strength, then these neurons will not support new learning. So the idea is during sleep, we reset the synapses back down to a baseline level. So we have to weaken the synapses so that they can be strengthened again for new learning. So sleep is restoring plasticity in the hippocampus, preparing the hippocampus for new learning. That's the idea among scientists today. So the hippocampus learns fast, but it forgets quickly. So here we have the hippocampal neurons. Notice one learning event can dramatically increase synapse strength, but then when we go to sleep, we weaken those synapses again. And the purpose of that is to prepare the hippocampus for new learning. Whereas in the cortex, remember we said there was lower plasticity, so the cortex learns slowly, but it forgets slowly as well. So notice it takes several study sessions to really strengthen those cortical synapses, but once you get them strong, the idea here is that those synapses stay strong. There is slow decay, and of course that's a good design for the long-term memory system. If we store information strongly in these cortical memory traces, we will have strong memory traces for the rest of our lives. So there are two memory functions for sleep. First, we're going to be consolidating memories. We're going to strengthen cortical memory traces using the hippocampal memory traces as our way of doing that. We're going to reactivate hippocampal memory traces and strengthen those cortical traces. And secondly, then, we're going to weaken the hippocampal memory traces to prepare the hippocampus for new learning. In this diagram on the left, then, Notice, though, the timing of these events. We need to do the consolidation before we do the erasing of the hippocampal memory traces, right? We need those hippocampal memory traces to strengthen the cortical memory traces, and only after that can we afford to weaken the hippocampal memory traces in preparation for new learning. So why does the brain consolidate memory in the cortex? We could summarize it as follows. We consolidate memories in the cortex because there is more storage capacity in the cortex, and cortical memory traces decay slowly. In addition, the hippocampal memory traces are being erased in preparation for new learning, so we must save recent memories to the cortex before the hippocampal memory traces get erased. In the next lesson, we'll look at the importance of repeated study sessions.